Hello, I'm Dr. John Morris. I'm the president of the Institute for Creation Research, and here we are at the Institute for Creation Research's Museum of Creation and Earth Science. And I'd like to just talk to you a little bit about the Grand Canyon, as you see here, and some of the other things that have to do with geology and rocks and fossils. There's a tremendous message that we can get from the rocks and fossils that help us understand Earth history. Here at the Institute, we do a lot of research. We've done over the years decades of research in Grand Canyon. And there's some very interesting things that we can talk about there. Things that normally have been censored out of your education, and you've not heard about them, probably. So let me just kind of whet your appetite and draw you in to search for some of this information in a more permanent form. One of the things that we always talk about with Grand Canyon is how was it eroded? How did it get here? Over the years, we've been told that the Colorado River down at the base of Grand Canyon, migrating back and forth over millions of years, have carved out Grand Canyon. But there's been a lot of people studying that issue. In fact, even my evolutionary colleagues, they pretty well concluded that the Colorado River could never have carved Grand Canyon. It's the wrong kind of river. It would never carve a canyon like this. Rivers, when they erode the bank. I mean, that's where all the inertia of the water is. They widen the bank, perhaps, and there's a flood plain. But how can a river erode through solid rock straight down? I mean, there's some pretty well-known parameters that have to be met for that. The Army Corps of Engineers has been studying this problem for years, but as they do flood control and things. And so we know how a river can erode, and what would make it erode down. Come to find out, the only way that a river such as the Colorado River could erode down is when there's a huge volume of water flowing at a rapid speed, rapid enough to remove all the sediment from the bottom of the river, and so that it's actually interacting with the rock below, and then, especially with the particulates in the water and the abrasion that would be caused, it can erode down. Normally it erodes to the side, as I say, but in this case it erodes down. It's called an incised meander. A meandering river has incised itself into the bank. The story that we've always been told is that the Colorado River was an ancient river that flowed through this area, but then as the ground was uplifted from basically sea level, because all these rocks are ocean bottom rocks, and so the idea is that it's been uplifted and that erosion kept pace with the uplift and continued to carve down, down, and down as this rose up and up and up. They say that took 65 million years or so. But the more study has gone on, as I say, they've given up on that idea. They've found lava flows or a volcano from the north side of the canyon. Sometimes you can find the same lava flow on the south side of the canyon. So it obviously erupted after the canyon, because it certainly didn't flow across the canyon, or it would have fallen in perhaps. But how do you get it on the uplifted south plateau, including the north plateau? And so they said, well, the eruption happened after the erosion, but the lava itself has been dated. It's been dated by radiometric means, and has been concluded that it's within the last few million years. Now, I'm not sure I buy that date, but what they're saying is that the lava flow is more recent than the erosion, and the lava flow is like the last thing that happened in this region. So the canyon itself evidently is recent. Well, we've put it all together, and in fact, sort of the dominant view among geologists now is that some huge volume of water came through this area and carved this canyon out rapidly. A lot of times they talk about a lake that collected to the north and east of Grand Canyon. This lake would have been actually about the size of Lake Michigan, a huge inland lake. And it was held in place by the mountain that forms Grand Canyon. The river itself, the canyon itself, goes right through that mountain. And that's why it's such a dramatic canyon. It should be a mountain, but the river goes right through the canyon. And what would cause a breach in this natural dam, this uplifted plateau, that could allow this canyon to be formed? Well, we suspect that this lake built up north and east of the canyon, and through some sort of an instability, maybe piping, kind of water tunneling through the mountain, and caves developing in there, and caused a zone of weakness, which then it failed and burst through that failed dam, and a lake the size of Lake Michigan then poured out of this area. Maybe it overtopped the dam and notched it down, and then once the water started coming, it kept coming and coming and dug out this canyon. The evidence seems to support the idea that lake the size of Lake Michigan drained within a week or so. I mean, it would take some time to get all that water out. And in that time on which that water was just pouring out at huge velocities, and at a great velocity and with huge volumes, it could carve a canyon like this in a relatively short period of time. There's all sorts of evidence here at Grand Canyon that support the idea that rapid erosion took place, and there's other evidence that the rocks were still in a soft, unconsolidated condition at the time it formed. As you see, one of the dominant erosional patterns in the canyon today, I mean, the canyon rocks are hard. I mean, they're hard. They're hard as a rock. They are rock. I mean, they're just hard rock. Hard rock erosion is typically jagged, and it's broken. And we understand hard rock erosion, but we also understand mud erosion, soft rock erosion. And typically that fails in a semicircular pattern. Ground surfaces slip along that semicircular amphitheater-headed side canyon pattern. And if you look in Grand Canyon, everywhere you look, you see that amphitheater-headed side canyon. It's the dominant erosion pattern in the area. Well, there is some hard rock erosion too. It's along the fault zones and stuff. But the dominant erosion pattern is this semicircular amphitheater-headed side canyons. That would only set up in mud. It really would never form in rock. And so, you know, there's just some things here that we're not being told about Grand Canyon that have not been noticed. Well, I think Grand Canyon is basically a relic of Noah's flood, of the great flood of Noah's day. I think all these sedimentary rocks that you see there on the opposite side of the canyon are sediments laid down by the moving water of the great flood of Noah's day. That's what floods do. I mean, that's what water does. Water erodes over here, redeposits over here, and then these layers of sediments can harden into rock. It takes some time to do that. It doesn't take millions of years. It takes weeks or maybe months or years. But it doesn't take millions of years. Just like your sidewalk in front of your house, that's like a man-made rock. That's set up overnight. You know, it takes a while for the cement to bond the particles together into a solid rock. The concrete of your sidewalk, it's very similar to a rock. Well, that's the same thing with the rocks. There is some time involved, but it doesn't take a long period of time. We have no knowledge of what would take a rock millions of years to solidify and to harden. All that we know about happens relatively rapidly, and yet these rocks seem to have been still in a soft, rather unconsolidated condition at the time of erosion. And that erosion took place not very long ago. I think the evidence here is overwhelming that the canyon itself was, that the rocks themselves were laid down by a great flooding event, and then were eroded by the draining of these floodwaters back into the ocean. The evidence fits with the biblical idea of the great flood of Noah's day. The Institute for Creation Research, let me invite you to come and visit the museum. I think you'll really enjoy it. You'll see a lot of things that you've not seen before. These scientific evidences that are kept from the education of most people, but yet the evidence is here. And let me show you some of this, particularly again as we're looking at Grand Canyon. This is a model of Grand Canyon in several statewide, covering several states. I mean, it's a larger model from Arizona up to Utah. Grand Canyon is here. You can see this notch. Think of a huge lake north and to the east of Grand Canyon that then somehow that natural dam failed and it began to erode out. It eroded quickly, it looks like. The evidence indicates a rapid erosion event and rocks that were not completely solidified. Well, I think it was Noah's flood. I think Noah's flood is responsible for it. Now, the great flood of Noah's day, that's not something geologists normally talk about. Well, I'm convinced it's the flood. I'm a geologist, but I'm also a Christian. I'm a Bible-believing Christian. And I really think that the Bible tells us accurate history. And I think that geology supports that actual history. I think Noah's flood is one of the strongest doctrines in the Bible, but it's also very evident in the rocks. Let me show you here at Grand Canyon what you're seeing. You're seeing, basically at Grand Canyon, what you see when you look at the side of Grand Canyon, you're seeing all these horizontally bedded strata. Well, those bedded strata, that's like the side view of a stack of pancakes. I mean, you're just looking at them they've been eroded off, and you're looking at the edge of the pancakes, but these pancakes are huge. If a worldwide flood is responsible for all of this, what would you expect to find? You can make predictions. I would expect to find the results of that flood to be continental in scope. I mean, maybe it didn't do the same thing all over the globe at the same time, but it would do huge layers of things. These pancake layers of sediments would be huge, and maybe cover the continents or a major portion of the continents. And as we look at these rocks, we see that demonstrated completely. Here at Grand Canyon, you have this whole suite of pancakes that are called the Grand Canyon series. But as we trace them northward into Utah, we see that those pancake layers go even farther. And we see that this erosion of Grand Canyon is only the last little bit of erosion that has taken, it's eroded all of the western United States and then finally localized in Grand Canyon. This was a huge depositional as well as erosional event. But let me call your attention to the lowest pancake layer. If you can see up close this orange-looking strata layer toward the bottom of the Grand Canyon sequence. In fact, it's the lowest horizontally bedded strata in Grand Canyon that covers significant areas. There's some local ones in here too, but this Tapete sandstone, which is the lowest horizontally bedded layer, that's full of fossils. It's got a lot of fossils in it. The ones below it have no fossils in it. They're a different kind of rock. But this Tapete sandstone, it's evident there at Grand Canyon, but then it goes all the way north into Utah and up into Zion Canyon, and it's exposed at Bryce Canyon. It's a huge layer of rock. In fact, we have then plotted the aerial extent of the Tapete sandstone, and well, of course, that's called the Salk sequence, the bottom layer of that being the coarse-grained Tapete sandstone going into a small sand grain size sandstone, but then the overlying Bright Angel shale, and then the overlying limestone. This is a sequence from the coarse grain sandstone up to the shale up to the limestone. That sequence is found basically all around the world. It is a worldwide sequence. The lowest level starts with the coarse grain sandstone and then goes up to a limestone. It's remarkable. It is found all around the world. Even this Tapete sandstone. as you trace it laterally into its the same bed, the same sequence bed. Well, you find it up in Utah for sure, but you also find it in Wyoming, in Colorado, and Montana, and North Dakota, and you find it in Illinois, you find it in Pennsylvania, you find that it covers most of Canada, you find that it goes around and it covers part of Greenland, and it covers part of Europe. I mean, that layer of rock, that pancake, covers much of the northern hemisphere. Some huge, huge event caused that to peat sandstone and the overlying beds. That's consistent with Noah's flood. You remember we asked the question, what would the results of Noah's flood look like? What would we expect to find? My evolutionary colleagues say there's no evidence for Noah's flood. I say, what are you looking for? The evidence fits Noah's flood. I mean, that layer of rock covers a huge area. And then when we start looking at what kind of event would lay down that kind of sandstone. Sand, we know how water moves sand around, but this sandstone has certain kind of cross bedding in it that require a certain depth of water. It looks like the peat sandstone was laid down under maybe a couple 100 feet of water in the bottom of the ocean, but that this water was moving at a certain rate. And we know we've done many experiments on this. The velocity of water necessary to carry along a sand grain size of normal diameter, we know what kind of water can do that. Well, some of the grains in this sandstone are as big as a room. I mean, they're as big as a house. I mean, they're huge. The basal conglomerate of this sandstone. But the normal sandstone is a certain grain size. Well, what kind of a water velocity would do this? And of course, it has to be at depth, 200 feet depth or so. We can measure that by the geometry of the crossbeds. Well, it looks like that the water velocity necessary was like several meters per second. Now, several meters per second doesn't sound too fast. You can almost run that fast. But can water flow that fast, 200 feet deep? Oh my, we've never seen that. We've never seen that. We see lakes, we see oceans, we see, there's a lot of water and there's movement in that water, but to go fast enough to carry along these large grain size sand grains, you have to have that velocity. And we just can't even imagine what kind of a flood would, at 200 feet depth of water, carry along these sand grains of these large sand grains. Well, Noah's flood would do a thing like that. We would predict that the results of that flood would be continent-wide in scope, and it would give evidence of catastrophic conditions. And that's what we find, particularly in the peat sandstone, that these water velocities were several meters per second covering the northern hemisphere. Now that's a catastrophe beyond our minds can even comprehend. Yeah, we can think of a hurricane and stuff, but a hurricane that affects water 200 feet deep with a large velocity of water, we just can't imagine it. And then when we go on up to the other levels, oh my. The whole thing just appears to be the conditions are so varied, but they're all catastrophic in nature. It looks like one whole series of catastrophes did the sequence, both at Grand Canyon and then in the northern part of the area where they've been eroded away. Something very different was going on in the past. Something catastrophic. Something very similar to the great flood of Noah's day, which is described in Scripture. Our predictions about the flood have been confirmed. The evidence supports what the Bible's been saying all along. There's one other rock I want to call your attention to here in Grand Canyon. It's about halfway down. It's this thick pink-red zone here. It's called in geology, it's called the red wall limestone. It's a major cliff-forming zone in Grand Canyon. It, of course, also covers much of the western United States. But it is true that most of the layers in Grand Canyon have been reinterpreted by geologists to be catastrophic deposits, to be the result of major events in this area. Well, except the red wall limestone. In fact, in geology, this is kind of the standard bearer for slow and gradual calm, collection of sediments at the bottom of a calm ocean. It's similar to in the Caribbean Ocean, that it's very calm and things just settle out, and it takes a long time, and it would take calm conditions. And they would say this is the major contradiction to the flood prediction. This layer, the red wall limestone, proves slow and gradual calm conditions. Well, I think it's right in the middle of Noah's flood. And so I think there's got to be some evidence there for catastrophe, for major event, flooding to be going on. Well, and so we've been studying it. We've turned our attention to this. It's interesting. There are almost no fossils in Grand Canyon. Yeah, there are some here and there, but a lot of them were just broken and tiny things. There's some battered coral and just rubble. But there's hardly any fossils at all. But here in the red wall limestone, about 20 years ago, a set of fossils was discovered in a side canyon along the banks of the Colorado River. You have to climb to get to it. It's hard to get to. It's something that nobody would go to unless they were exploring for geologic purposes. But they found these fossils, and they're kind of what we call ghost fossils. They're not really there, but if you wet the rock down, these things will kind of stand in contrast to the other rock. And so you can see the features of the fossil. They're called nautiloids, like a nautilus, like a chambered nautilus of today, but a nautiloid. It's not coiled like our modern-day nautilus, but it's elongated with a cigar-shaped, like a cigar-shaped thing. These are about 2 feet long. And so we were up there one time studying these fossils, and they're very interesting from a scholarly point of view. But we got to wondering, you know what? We think Noah's flood laid down this layer of rock, along with all the others in Grand Canyon. And so we would predict that there would be evidence that these fossils were laid down by moving water, and that didn't just fall out of the water, just settle to the bottom as they died. And so we said, I wonder if these cigar-shaped fossils are oriented. And we put our compass down and measured all these about 20 or 25 fossils, and sure enough, they showed a preferred orientation. They were laid down by moving water that was moving in a particular direction. Oh, well, that's helpful. We now know something more about the flood. But then we said, the flood was large, and of course the red wall limestone covers much of the western United States. I wonder if there are other examples of this fossil in the next canyon that nobody's ever found before. Well, we went to the next canyon. Again, it's hard to get to. I understand why nobody had found these things before, but we went to that same layer. It's in the middle of this layer that's several hundred feet thick, and then there's a 6-foot layer in the middle of that, and then right in the middle of that 6-foot layer is this one zone that has these fossils in it. Well, we knew what we were looking for by that point, and so we went to that layer, and sure enough, there were some more fossils. And we measured their orientation. They had the same orientation. And then we went to the next side canyon and did the same thing and measured their orientation. This pattern of moving water, the remains of fossils oriented by moving water were found in several canyons. And then now we've gone to the whole area. We've gone up into the adjacent states, into Nevada and Utah and Colorado and Montana, and begin to find these things, and they cover a wide area. Oriented in a catastrophic deposit, and again, this is evidence of Noah's flood. This classic rock unit, which was thought to prove slow and gradual deposition, really has evidence of flood conditions as well. It appears that this was not just moving water that did this, but this was an underwater gravity flow, a mud flow flowing down a minor slope, but it covered these things in a mud flow. That the mechanics of mud flowing like that are known, and so we've been putting that all together. It looks like this mud flow covered a huge area, and whatever fossils were susceptible to being buried at that point in time laid them down. Even the red wall limestone gives evidence of flood catastrophe over a large area, just like we were thinking. These nautiloids in the red wall limestone, here are some similar ones from Morocco. This is a very famous deposit, but it's the same sort of thing. It's the nautiloids. Evidently at that stage in the flood, things were going on around the world, and these nautiloids were deposited by the trillions there in Morocco. Here in Grand Canyon, we found them at an average density of 1 per square meter over billions of square meters of area. It's an incredible kill zone of nautiloids. But here in Morocco, you find some of the same sorts of things. Notice that these nautiloids, it's like a squid with a shell, and that shell not rolled up. But these things, as they were deposited there in Morocco, again, they're oriented. They're all in the same direction. It just shows that something was happening at that stage in the flood that was just right for depositing organisms of this density and this character at that same time worldwide. Let's summarize for a moment what we've been talking about. I'm convinced that the great flood of Noah's day deposited and laid down the world's record of rocks and fossils. Wherever we see rocks and fossils, we're probably talking about the remains of, the effects of Noah's flood. But Noah's flood, of course, is outside the realm of our experience. We didn't see that. We've never seen a flood of that magnitude. But yet we see the signature of it. We see the evidence. The only thing we can do at this point, what scientists must do, is ask questions. What would I expect to find? If Noah's flood really did happen, what would I expect to find? My evolutionary colleagues would say that I think things were slow and gradual, and what would I expect to find? Well, as a catastrophist, as a believer in Noah's flood, I would expect to find that all of these layers were laid down by catastrophic processes, and that they were continental or even global in scope. My evolutionary colleagues would say, no, I think they're slow and gradual, and they're only local in scope. It would be due to stream bank erosion, or maybe beachfront or lake bed, or some local thing, or a delta. These are all local depositional events. Well, I would predict that we would be talking about things that are continental in scope, maybe even hemispherical, and possibly even global, because Noah's flood was a global event. Well, when we go to the rocks, here at Grand Canyon in particular, we find evidence that these rock units are incredibly catastrophic in their nature. That Tapete sandstone down there at the bottom, that thing gives every indication that it was an underwater flow of sand that required water movements of several meters per second, and it covered the northern hemisphere. In fact, even my evolutionary colleagues recognize that the Tapete sandstone appears to have been deposited by a series of underwater sand flows at up to 90 miles an hour. 90 miles an hour! What kind of a catastrophe are we talking about here? One that covered the northern hemisphere. I think we got to be talking about Noah's flood. And then we talked about the red wall limestone and how that has always been thought of as the proof of slow and gradual deposition. But then right in the middle of that red wall limestone, which is in the middle of the whole stack of Grand Canyon pancake-like layers, right in the middle of that sandstone is this layer of nautiloids that seem to be oriented by moving water, and as best we can piece it together, it's an underwater mud flow, a gravity flow of muds that, again, covered the northern hemisphere, covered most of the United States, most of the western United States. It was huge. It was catastrophic. That's just what we predicted for the flood of Noah's day. Well, we could make some other predictions about the flood. We could talk about radioisotope dating. We could talk about the tectonic forces involved. But all of the predictions of the flood model would be satisfied by the rocks and fossils of Grand Canyon. They are supportive proof that the biblical doctrine is correct. As scientists, we don't try to prove the Bible. We don't try to prove the Bible. The Bible doesn't need our help. It just needs to be believed. But if it's true, it's got to be supported by the evidence. And I think it is. Remember Jesus, when he was talking to Nicodemus in John chapter 3. John 3:16, he says, Nicodemus, he says, if you don't believe me when I tell you about earthly things, how can you believe when I tell you about heavenly things? Well, he was talking about being born again and about going to heaven, the heavenly things. And he says, but I've also talked to you about natural things, normal earth things, things that you can check. He talked about the wind and different things. And if I've told you about earthly things, he said, and you don't believe me, how can you believe me when I tell you about heavenly things? Well, these earthly things that he talked about and that the Bible talks about creation and the flood and things that can be, in principle, checked. And whenever we check, we find out that his account is accurate. It's true. And it gives us a reason to believe, a reasonable faith to believe that these heavenly things that he talked about are true as well. He said that his death on the cross paid the penalty for our sins. There's no scientific observation we could make that would check that out. But we believe him because everything he said that we can check out, checks out. He said that he's preparing a place for us in heaven if we believe him, believe in him, that the death of Jesus Christ on the cross paid the penalty for our sins, that he's preparing a place for us in heaven. Obviously, we can't go to heaven and check that out, but we can believe it. I think it's a reasonable faith. It does take faith to become a Christian, but it's a reasonable faith because all the scientific facts line up with it. God's word is accurate from cover to cover, even these early chapters of Genesis, but especially the New Testament where it talks about Jesus.